you. Very good morning to all of you. University Grants Commission is very pleased that much needed platform is now created for Sri Lankan experts from universities, institutes, boards, departments, ministries representing diverse fields, social sciences, natural sciences, water, irrigation, agriculture, engineering, and medicine, to come together to address this major national problem, CKDu. At the outset, may I also thank the Chief of the Presidential Task Force, Mr. Asili Devela, for requesting the University Grants Commission and the University of Colombo to facilitate this. May I also thank the Vice Chancellor of the University of Colombo, my friend, Professor Lakshman Disanayak, for providing the leadership and the facilities at the University of Colombo for several meetings we had prior to this main meeting, and which has now led to this symposium. The main aims of this symposium are, firstly, to systematically evaluate the research all our experts have gathered so far. Secondly, to identify the gaps in our understanding of the role of arsenic, cadmium, fluoride, ionicity, and infection as causative factors and as risk factors. Thirdly, to identify any other hypotheses in our understanding of the etiology. And finally, all this will lead and to establish a consortium of researchers, both national and international, to conduct long-term multidisciplinary research to understand the etiology of chronic kidney disease of unknown origin. If I may explain now how it's going to happen. The first scientific session will start with Professor Saroj Jayasinghe. He will give an overview of the research conducted in Sri Lanka. Then, 8 Sri Lankan expert researchers will present their research on identified themes. First, the role of arsenic and agrochemicals. Second, the role of cadmium. Third, the role of fluoride and ionicity. And finally, the role of infections. I must thank all the researchers for their commitment and their valuable contributions in advance to understand this complex problem. All expert presenters have been provided with a template in advance. They will adhere to the template submitted to them so that the learned audience can contribute by discussing the strengths and also by identifying the gaps which will create new knowledge and understanding of the problem. Professor Rizvi Sharif, Dr. Chula Herat, Dr. Palita Bekon, and myself will chair the 4 sessions. Together with the rapporteurs, and at the end of the presentation of each, the rapporteurs will summarize the presentations before discussion. There will be independent expert reviewers who will give their comments based on the template. The discussion will be a guided discussion to fulfill the epidemiological and laboratory criteria of causality, and to identify the gaps to understand what we already know, what we do not know, additional evidence which may be needed, and related hypotheses to be explored too, in order to understand the etiology of this disease. And I hope I made clear the way in which it's going to be conducted, because we feel that this is extremely important high-level scientific forum. May I conclude by thanking all the expert researchers from our country for their interest, the work done so far, and also agreeing to speak here. Thank you.
Thank you, sir. Representing the University of Colombo, Professor Saroj Jayasinghe, Professor of Medicine, University of Colombo, will present to you an overview of the etiology of CKDu in Sri Lanka.
Thank you very much. Good morning to all of you. Professor Mohan Silva, Professor Lakshman Disanayaka, Mr. Asela Iddabela, sponsoring and funding institutions, ladies and gentlemen. My task is to give you an overview of the problem related to CKDu, and I will be focusing from a global point of view and try to narrow it down to the local situation, geographically as well as conceptually. Since it's a diverse audience, I will be starting with very simple descriptions, and I apologize to some of my medical colleagues in advance. These are the four main areas: the global epidemiology, some of the pathology and mechanisms which have been described globally, some of the hypotheses which have been put forward, again at a global level, and then narrow it down to the Sri Lankan four hypotheses, which will be discussed over the next 48 hours, as it were. This is a global epidemic, and I think it's important to realize that we are not alone. And we should always learn from what's happening elsewhere so that we will be able to advance our hypotheses as well as advance our research, compare with the rest of the world. A disease very similar to what's happening in Sri Lanka is seen in South America, El Salvador, Nicaragua, now even in Peru. It's there in Egypt, Tunisia, parts of India in Andhra Pradesh, and of course in the north central province of Sri Lanka. And Professor Mangala from Ruhuna has now shown that it might be even spreading elsewhere. So the burden of this global epidemic, some call it a pandemic, because it's affecting so many areas of the globe. Innumerable number of people are affected and people are dying. It's affecting the health system, and there is immense impact on the individuals who die a slow death, on the impact on families, their socioeconomic standing. It affects communities, it devastates. Basically, Sri Lanka is facing a catastrophe. If we do not do something about it, we will probably have a situation where North Central province gets depopulated. And it's going to change the dynamics of this country. Now I'll just outline to show you that there's something seriously going on in different areas of the world. The mortality from CKD has gone up several fold in some of the South American countries or Central American countries, threefold or sevenfold. Deaths have been noted even in Andhra Pradesh and in Egypt, where an increase in the prevalence of end-stage renal failure has shown an increase. So we are sure that there's something seriously going on. This is not because we are diagnosing them early, not because we have better tools for diagnosis. There's something seriously going on. Even in Sri Lanka, the figures are not precise, but roughly about 2,000 people are dying annually from CKD. The morbidity is probably affecting 70,000 or more, and in some of the population-based surveys, there is a high prevalence of the disease in adults. And remember, this is affecting middle-aged or young people, not the traditional group of people who have diabetes, hypertension, and chronic kidney disease. This is from a publication from Sri Lanka showing the high prevalence of chronic kidney disease in the different provinces, and you'll see North Central province way above the rest. So in Sri Lanka also, there is something seriously going on. No denying that fact. Now, the next few slides, I want to mention to you about the kidney. There are nephrologists, eminent nephrologists here, some of whom are my teachers, but I will briefly try to explain a few facts about the kidney. The kidney gets a disproportionate amount of blood flow compared to other organs. And it's mainly concentrated in the cortex. About 80% of the blood flow is used by the oxygen is used by the cortex. So it's a very highly metabolically active organ where certain parts of the kidney are doing a lot of work. And that lot of work is trying to excrete compounds. So you are able to concentrate and excrete some of the toxins. Sometimes the concentration goes up to 50 times what is there in the plasma. Now, one thing you have to remember is this idea of CKDu. It's not something like tuberculosis of the kidney. Tuberculosis of the kidney, you see the bacteria, and you know it's an infection caused by a particular organism. CKDu, when we look at the histology, that's when you look under the microscope, it shows a lot of fibrosis. Now in this previous one, on the middle is what they call the glomerulus. That's where the filtration happens. And the circle areas are actually cross-sections of the tubules, which concentrate and start producing the urine. And you'll see those red areas are thickened, and the round areas are encircled by red areas, which is actually fibrosis. So you have fibrosis and inflammatory cells, leukocytes, mainly lymphocytes, plasma cells, and even neutrophils. And there's a lot of fibrosis. Fibrosis is probably a key factor in the progress of the disease. And when you look at the biopsies, you see what we call chronic interstitial nephritis. Now, that's the end result of several pathways. So this is why I say you shouldn't look at it like TB of the kidney. Several different toxins, insults, injuries can ultimately lead to the same pathology, chronic interstitial nephritis. It could be repeated attacks of acute interstitial nephritis, which go into chronic interstitial nephritis. And if we compare the pathologies described in different parts of the world, there are some variations. In most of the studies in Sri Lanka, especially done in Peradeniya as well as in Jayawardhanapura and Kurunegala, several of the authors are here, there is a lot of interstitial fibrosis, the tubules atrophy, there are changes in the glomeruli, and there is involvement of the blood vessels. There are minor variations compared to other countries. For example, in Central America, they don't describe much about the vascular changes. But again, remember, this is the final common pathway. And it is several different factors can give an almost similar result. And when you have this chronic interstitial nephritis, the glomeruli can get affected secondarily. That is, after the interstitial area is affected. Now, if you look at the mechanisms of how this whole process, we tend to take a fairly simplistic look of looking at it from the different insults causing a decline in the glomerular filtration rate, that's a function of the kidney, which ends up with chronic kidney disease, and we, under certain criteria, we name it as CKDu. The mechanisms we commonly think of would be direct toxic effects, mainly direct toxic effects. So there are hypotheses in relation to fluoride plus cadmium plus hard water, especially Vasana's paper recently in the Scientific Communications, I think, a Nature publication, an excellent publication, and also effects on of increased ions in the drinking water, leading to a form of denaturing of proteins. So these are direct effects. Even in South America, the so-called heat stress and fructose-based mechanism, they have worked on that quite a lot. And they describe a very complex set of pathogenic mechanisms which can account for the damage to the kidney. But remember, I've just written in green some of the other mechanisms which can cause renal damage. Not only direct toxic effects. You can have immune damage, which we haven't really looked at in detail. The immune systems may lead to a chronic interstitial nephritis. I mentioned about fibrosis, the importance of fibrosis. So oxidative stressors in the kidney leading to certain cytokines. The TGF is actually a cytokine, transformational growth factor, which induces fibrosis. I mentioned to you about the fibrosis being an important part. So there are cytokine-related pathways. We don't know how low birth weight interacts, because if you have a low birth weight, you will have less number of nephrons or smaller nephrons, and the kidneys will go into, you'll have an accelerated progress into renal failure. And finally, epigenetic mechanisms. We haven't really even considered those. Epigenetic mechanisms are where your genes are being altered, either methylation or changes to the histones. Your genes are being altered by the environment. Pesticides, persistent organic pollutants are well-known products which methylate your DNA. And these can go down generations. If the mother is exposed to a contaminant, the newborn will be affected. These mechanisms have not been elucidated or looked at. So if you look at hypotheses, for the different areas there are various viewpoints which are coming in. And again, it's important that we know the hypotheses being discussed in other countries. This is a summary which was recently published in Kidney International Reports. And you will see in blue some of the etiological factors: heat stress, strenuous labor, heavy metals, communicable diseases, agrochemicals, and genetic predisposition. As I mentioned, in Central America, and the groups in America have worked a lot on the heat stress and strenuous labor, and they have described the mechanisms in fairly great detail, including the fact that you have rehydration and dehydration alternating in people who are sugarcane workers. They are drinking a lot of fructose-rich fluid, which can also cause damage to the tubules. and so on and so forth. And rhabdomyolysis, subclinical rhabdomyolysis, where because of physical exertion, your muscles are breaking down, and that those proteins get converted to uric acid, which can damage the kidney. So they have tried to bring in this heat stress nephropathy and this trying to link it with climate change. So these are some of the hypotheses, and if I were to superimpose some of the things which are being researched here and going to be some of the major topics during the next 2 days, communicable diseases, we have work on leptospira and hantavirus, especially from Peradeniya. Then there is a lot of interest on heavy metals, cadmium and arsenic from Rajarata as well as from Sri Jayawardenapura and Colombo. Then we have agrochemicals, the role of glyphosate, again mainly from Rajarata. The genetic predisposition, the work done by Nanakar et al. From Peradeniya. And we have a lot of work, especially by groups involved in geochemistry, on fluorosis, cyanobacterial toxins. And the role of fluoride will also be discussed during the next 2 days. So all these are some of the hypotheses, and I put this up to show you the link to some of the work which is happening elsewhere. And if you go through the publication, they give you a few more details of the etiological factors that different countries have discussed and proposed. So you have the Indian CKDu, the Egyptian CKDu, Tunisian CKDu, etc., describing different etiological factors. Now, if you look at the studies which have looked at the risk factors listed on the left: alcohol intake, snakebite, herbal use, smoking, tobacco use, family history, ochratoxin, dietary exposure, BMI, occupation, male age, etc. On the right are the dark blue are the studies, the number of studies which have definite positive results or positive correlations. The dark red are the negatives. The light blue is non-significant positive, and pink is non-significant negative. And you will see that if you collate all these studies, n equals 11 or 13, can't remember exactly, the authors have listed or illustrated the amount of evidence, the weightage of evidence to the different factors. So you have alcohol, snakebite, herbal use, tobacco use, family history, occupation, definitely positives, hardly any negatives on those. Then a negative relationship with BMI, positive with farmers, farming occupation, being male, age, low altitude, temperature, and so on. So some of the evidence, for example, agrochemical use, there is positive as well as negative studies. Heavy metals, again, positive as well as negative. So this has, in fact, this sort of occupational or regional number of prevalence, increase in prevalence has led to the new name, which is accepted by the Oxford Textbook of Nephrology as chronic interstitial nephritis in agricultural communities. Now, if you were to link up all this in a graphic manner, these are the hypotheses which we have so far seen. And if in blue are some of the specific areas which studies have been done in Sri Lanka. So out of the contaminants, mainly there is on arsenic, cadmium, fluoride, hardness of water, and of course pesticides have been also mooted in Sri Lanka. We have also looked at, there are studies on genetics, leptospirosis hanta, and on snake bite in relation to CKD. Vasana's study and the group from Peradeniya have tried to combine the synergistic effect between cadmium, fluoride, and hardness of water. Now, today, actually, we are going to focus on these areas. So it's important to think of this in context because we are actually focusing on a fairly narrow area to see whether it's what's the sort of evidence we have and for and against, and the rapporteurs will also comment on the evidence being presented so that we will move forwards in relation to these areas, and also if way forwards we could think of the other areas which I've touched upon which is given in a lighter color in this slide. So thank you very much, and again thank you to the organizing committee for giving me this opportunity to speak to you. Thank you.
Thank you, sir. That brings us to the end of the inauguration session. To commence this session 1 on research evidence on the role of arsenic and agrochemicals on the etiology of CKDu in Sri Lanka, I cordially invite Professor Mohan De Silva, Chairman, University Grants Commission, the chairperson, to take over the proceedings.
We'll commence the session 1, and the session 1 is on the research evidence on the role of arsenic and agrochemicals on the etiology of CKDus in Sri Lanka. There'll be 2 presentations. First by Dr. Chandra Jayasubramanian from Rajarati University of Sri Lanka, and second presentation is by Professor Mangala De Silva from University of Runa. Each presenter is allocated less than 40 minutes for their presentations. And the presenters have agreed to follow the template provided to them. And the templates are provided in your folders as well so that you can follow this, for which a reference material 2 is given, which consists of existing evidence updated in April 2016, burden and hypothesis in Sri Lanka, and the report published in April 2016 meeting of the WHO and the Presidential Task Force on CKDUs. At the end of the presentations, the rapporteurs allocated to each section of this presentation will be preparing notes, and I've been given the responsibility of presenting to you the short summary of what is submitted to me by the rapporteurs. After that, there is a set of reviewers which I will be introducing for each session, and they will make their own comments. They are the expert reviewers on the presentations based on the template before we open the floor for discussion, and this would be the format for all the chairpersons. And I hope during this discussion, which will be a guided discussion, we'll be able to systematically evaluate the research evidence presented by the expert researchers and be able to identify the gaps in evidence, and that is the way in which we are planning or proposing to go forward. Before I introduce the 2 speakers formally, may I invite the 4 reviewers for to come and take over for my session. And the 4 reviewers, and they'll come in front, are Professor Vasanta Gunatunga, Professor of Community Medicine, University of Colombo. I think he's here. Professor Upul Senarath, Professor in Community Medicine, University of Colombo. And Dr. Dulani Samaranayaka, Senior Lecturer in Community Medicine, University of Colombo. May I now take this opportunity to introduce our expert speakers. First presentation is by Dr. Channa Jayasumana. Dr. Channa Jayasumana is a senior lecturer of the Faculty of Medicine of the Rajarata University of Sri Lanka. And Channa is currently the head of the Department of Pharmacology of the Faculty of Medicine of this university. Dr. Channa Jayasumana obtained his MBBS degree from University of Peradeniya, joined the Department of Pharmacology, Faculty of Medicine, University of Rajarata University as a probation lecturer in 2008, and he soon obtained his PhD for the study titled Toxicological Aspects of Sri Lankan Agricultural Nephropathy from Rajarata University, with a foreign training component at California State University, Long Beach, United States. He also did a short training in clinical nephrology at Yale University Hospital in 2013. And he is a well-recognized researcher in this field, and he's very passionate in trying to find the cause for this dreaded disease. May I first invite Channa to come to the stage and to sit here. And I will also introduce a second presenter before Channa does his presentation, and that is Professor Mangala C.S. De Silva. And Professor Mangala C.S. De Silva is a professor in environmental toxicology of the Faculty of Science at the University of Verona. And currently, Professor De Silva is also the head of the Department of Zoology of the Faculty of Science of the university. And he, being an environmental toxicology expert, has done very significant research in this field. And may I also invite Professor Mangala C.S. De Silva to come to the stage, please. May I now invite Dr. Channa Jayasumana to the podium.
Thank you very much, sir. Good morning to all of you. It's an honor to make a presentation in front of this distinguished audience while excellent clinician and academic chair the session. So I would like to name the topic Evidence of Agrochemicals on the Etiology of Chronic Interstitial Nephritis in Agricultural Communities, because arsenic, according to our findings in the disease endemic region, originated from agrochemicals. So I'll modify the topic. So first few slides are a bit overlapped with what Professor Saroj said. So different names are given in different parts of the world, but we all know this is chronic tubular interstitial nephritis. Interstitium, its tubules and interstitium make up of approximately 80% of the renal volume and occupy the compartment referred to as the tubular interstitium. The interstitium is made up of both cellular and matrix components. It not only provides structural support for the individual nephrons, but also serves as a conduit for solute transport. It is also the site of production of several hormones and cytokines such as erythropoietin and prostaglandins. I give this introduction because of the latter half of the presentation, this anatomy and pathology is associated with our findings. In broad sense, renal disease, according to the origin, we can categorize them as glomerular, vascular, tubular interstitial, or obstructive. The term interstitial nephritis was first used in 1898 by English scientists describing a group of patients with systematic bacterial infection, primary scarlet fever and diphtheria. So it's a very old term. According to the WHO classification, you can see there are many etiologies for tubular interstitial diseases, infections, drug-induced tubular interstitial nephritis, and also it is associated with certain immune disorders, obstructive uropathy ultimately can result, and also certain toxic and ischemic changes. So recently, we renamed the disease as chronic interstitial nephritis in agricultural communities because there's a misunderstanding when we say CKDu or chronic kidney disease of unknown or uncertain etiology, because there are many kidney diseases with chronic kidney diseases with uncertain etiologies. But this is an unique clinical entity, and we know the pathology. It's a chronic tibial interstitial nephritis among agricultural communities. So to distinguish this clinical entity from other CKDUs, we precisely name the disease as CNAC, or chronic interstitial nephritis in agricultural communities. This term is accepted and will be published in the next edition of the Oxford textbook of medicine and Oxford textbook of clinical nephrology. In Sri Lanka, this is very important. First reported in 1994, almost all are young middle-aged farmers. Total number of patients, actual number we don't know. So this is very important. Let me read this. This was written by Professor Sam Kularatne, Professor of Medicine in University of Peradeniya. He was the physician in mid-1990s in Anuradhapura. It was in August 1994. I reported for duties as a consultant physician in General Hospital Anuradhapura, where I was looking after Ward 7, 4A and Medical Intensive Care Unit. I was one of the 2 physicians attached to the hospital, and the workload was enormous, but I enjoyed my day-to-day work. As I commenced my work, I found my wards were loaded with malaria, snake bites, organophosphate poisoning, yellow alien disease poisoning, Japanese encephalitis, typhoid, and hepatitis as outstanding problems. I took special interest in managing these diseases. However, in 1995, there were sporadic cases of CKD inviting my special attention. Then I realized number of CKD were increasing by 1996. In early 97, I carried out an audit on CKD related deaths in my male medical ward. The results astonished me, as more than 100 patients have died in 96. So this problem is all of suddenly appeared in mid-1990s. Because we know this is not reported by epidemiologists or by hospital authorities, first-hand evidence by a clinician. So this is compatible with the first official record kept by Mr. Hettiarati, then Assistant AGA of Padavisipura on 1994. He officially informed to Trincomalee AGA, government agent, about the unusual deaths of young male farmers in his area. Because you should remember, this area was subjected to LTT terrorism attacks, and this intelligent AGA thought of whether this disease is linked to something with this terrorist attack or terrorist activities. So he informed officially to the Trincomalee AGA. Actually, Mr. Hettiarati later became the Commissioner of Police Commission in Sri Lanka. So this is the geographical distribution. You can see the whole North Central province, part of the northwestern province and eastern and some parts in the Uva province are affected. And also geographically, it is spreaded over the time. It's spreaded over the time. So, but interestingly, there's no disease in the Northern Peninsula. Northern Peninsula is almost free of the disease. This is official data, published data. In North Central province, CNAC compatible cases are 70% out of CKD cases, but Northern province or in the Jaffna, it's almost 0. So it is something dealing with Anuradhapura, Polonnaru and adjacent areas. So this is the prevalence rate published in Jayathilaka et al. Study. So these are our findings. Clinically, they are basically asymptomatic, presented with loss of appetite, lethargy, backache, insomnia, arthralgia, especially in the knee joints, muscle ache, cramps, dysuria, and foamy urine. Stage of presentation at the first day of diagnosis, basically they present CKD stage 3 or 4, late presentation. Urinary findings, they are hypernatriuria, hypermagnesiuria, and hyperphosphaturia, hypercalciuria, and their early renal markers are elevated. Blood findings, they have serum creatinine, and they are hyponatremic. This is very important, hyponatremic and hypokalemic. Significant proportion of the CNAC patients are hyponatremic and hypokalemic. This is directly linked to the etiology of the disease. And they presented with elevated uric acid levels. Imaging shows bilateral small echogenic kidneys and decreased corticomedullary ratio. So histopathological findings show this is progressive disease, and these are our post-mortem findings. It shows chronic granulomatous appearance very much compatible with the post-mortem findings of Balkan endemic nephropathy. Here you can see the kidneys, post-mortem kidneys. So etiology, we'll go to the etiology. I feel there are no hundreds of hypotheses. There are two leading hypotheses: toxic nephropathy or heat stress and dehydration. These are the two competing hypotheses in the scientific world. And recently, infection origin, especially hantavirus and leptospirosis possibility, been discussed. So our opinion, cause for the disease is chemical nephrotoxicity aggravated by heat stress and dehydration. We published it about 4 years back. And this is the causes for the epidemic. Earlier I told this is the cause for the disease. This is causes for the epidemic. So we categorize, it is a 3x3 model. There are certain background factors: poverty, malnutrition, low birth weight, and certain groundwater conditions like high hardness, high fluoride level, and genetics. But essential factors are, according to our findings and view, chronic low dose exposure to multiple toxic metals like cadmium and arsenic, and certain chemicals originated from herbicide, especially herbicide residues and surfactants, and insecticide residues. Certain aggravating factors are there, like heat stress and dehydration, hantavirus infection, and snake bites. So this is the model we propose to explain the epidemic. So toxins. There are three kinds of toxins: naturally occurring substances like hardness and fluoride, naturally occurring anthropogenically introduced substances like cadmium, arsenic, and lead. For the disease endemic region, in Sri Lanka, cadmium, arsenic, and lead basically introduced through agrochemicals and man-made chemicals like pesticide and surfactants. So hardness. Hardness was not linked to any kind of tubulointerstitial disease till we pointed out in 2012. This was published in the Mesoamerican Nephropathy Workshop proceedings, and we proposed hardness may be a factor behind this disease. According to the medical literature, hardness can exacerbate certain eczemas, and it can exacerbate certain urinary calculi, and it has beneficiary effect on cardiovascular functions, but it is not linked to any of the CKDs. So first we proposed, hypothesized, hardness may be may play a role in this epidemic. So this is from the publication, Costa Rican publication. Fluoride. Then the second possibility, hardness. Yes, there's a possibility. Then fluoride. We believe fluoride highly unlikely as a single etiological factor for the disease, because fluoride is not recognized nephrotoxic substance in neither humans or in animals. It has limited evidences are there of nephrotoxicity of methoxyfluorine in human and sodium fluoride in animals. I think the chairperson may aware about this. In 1966, renal failure was reported in 13 of 41 patients receiving methoxyfluorine anesthesia for abdominal surgeries. In 2017, sodium fluoride induced nephrotoxicity on mouse renal tubular epithelial cells are proposed, but still, fluoride is not a recognized nephrotoxic substance. Second thing, animal studies show concurrent damage to liver tissues due to fluoride. It is not seen in CKDu patients. Similar disease is seen in meso, as Professor Jayasinghe correctly pointed out. We are not isolated. This disease is observed in certain part of the Central America, now in Latin America, in India, and in certain African countries. Similar disease is seen especially in Costa Rica, Nicaragua, and El Salvador, and in Udanam province, in Andhra province, where groundwater fluoride level is minimum. These data are published. It's about 0.2 to 0.5 milligram per liter. And at the same time, similar disease is not seen in high fluoride containing groundwater consumers around the globe, like in China and Ethiopia. Fluoride toxicity causes hyponatremia. So this is very important. These patients, SYNAC patients, are presented with hyponatremia. But non-fluoride toxicity cases are presented with hyponatremia. So this is against the common understanding, because here in this SYNAC basically damages in the S1 segment of the proximal convoluted tubule, but due to the fluoride, it basically causes damage to the S3 segment of the proximal convoluted tubule. And also, SYNAC does not show any correlation with dental fluorosis, which is a known complication of fluoride. And also, the earliest study on fluorosis done and published in 1974, even at that time, dental fluorosis was there 55 to 77% in 7 to 20-year-old school children in North Central Province of Sri Lanka. However, SYNAC is a late phenomenon. It was described in late or mid-1990s. Don't forget, our clinicians are excellent, and if there was this kind of phenomenon in the North Central Province, this would have been detected. They never miss. In a paper earlier we discussed scientific reports by Vasana. It clearly shows fluoride and hardness does not cause a pathological condition consist with SYNAC. But if you put small amount of cadmium, all of suddenly fluoride and hardness become nephrotoxic. So it seems to be cadmium is a catalytic in certain occasions where fluoride and hardness coexist. But if you carefully go through, you can see fluoride and hardness alone does not cause a pathology consist with the SYNAC. So what we have done? First we did the epidemiological study in Sripura with 125 patients and 180 cases, controls. In the univariable analysis, we detected male sex, engaging in farming related activities, pesticide application, applying fertilizers, drinking well water, and history of drinking from recently abandoned wells. Recently abandoned wells in the region are very common because of the distaste of the water. These are original data and published data produced by our group. Yes, then the multivariable analysis, we investigated the unconfounded effect of individual exposure factors after adjustment for age, sex, education level, having death among family members due to CKD and other exposure factors related to agrochemical use. Then we found drinking well water, history of drinking from recently abandoned well, and use of glyphosate were the factors significantly associated with CKDu. This is how glyphosate came into the field. Then we did individual pesticide versus SYNAC, and we found glyphosate usage and paraquat usage is significantly associated with, it has high odd ratio with the SYNAC. And not only glyphosate and paraquat, but certain other herbicides, especially bisvaribac, common trade name is the nomini, which is commonly used, and mancozeb fungicide, MCPA, M50 or herbicide, those are associated with SYNAC out of hundreds of pesticides used. So glyphosate and paraquat are the leading pesticides associated with the disease according to our epidemiological finding. Then we did analytical study, and we did comprehensive analysis of water in 18 abandoned wells and serving wells, 16 serving wells. Those are all from Sripura area, and we found certain amount of arsenic and cadmium, definitely which are not exceeding the WHO or upper limits for safe limits. And also we found glyphosate in the drinking water samples. It is about 3.5 micrograms per liter, and we don't have any upper limit or threshold level for glyphosate. We did analyze glyphosate because we found there's an epidemiological relationship with the glyphosate. And we published our data in an environmental health journal with a high, comparatively high impact factor. Then, a couple of years later, the scientists from UK, they categorically shown ultra low dose of glyphosate-based herbicide in drinking water causes SYNAC-like disease in rat models. Ultra low dose of glyphosate-based herbicide. So this is consistent with our findings. And we did certain other studies to show the people in the North Central Province are overexposed to pesticides. We did a significant study by using hair sample, which is the first in Sri Lanka in that type, and we found a lot of organophosphate-derived metabolites are there in hair samples, including housewives that have not worked in the field forever. So, compared to the findings from the other part of the world, our housewives are exposed 8 times to the organophosphates, but they haven't worked in the field. So it means there should be some other way of entry of these toxins, like drinking water, food, or airborne. So it is published in Environmental Research Journal. And we did a clinical study, basically urine analysis and histological study, phonation study. And each and every study shows, done by us and by other groups, there are 4 main nephrotoxins or toxic substances are there in their urine samples: arsenic, cadmium, glyphosate, and paraquat. Those 4 nephrotoxic or toxic substances, I'm not going to say those are nephrotoxic, it's up to decide. Arsenic, cadmium, glyphosate, and paraquat are the 4 leading toxic substances present in the urine sample as well as the post-mortem samples of these patients. Yeah, so these are the results of our analysis done at California State University, a well-recognized laboratory. And we published our data in BMC Nephrology, and we propose simultaneous exposure to multiple heavy metals and glyphosate may contribute to the Sri Lankan agricultural nephropathy or SINAC. Earlier we used the term Sri Lankan agricultural nephropathy, now we will into SINAC, because none of these chemical, if you take as a single substance, it seems to be not enough to produce this kind of epidemic in the region. Neither cadmium, no arsenic, no paraquat, no glyphosate. But in the holistic picture, the simultaneous exposure, synergistic effect may produce this problem. So we found arsenic and cadmium are basically originated from the imported triple superphosphate fertilizer. This fertilizer basically imported from China, Morocco, and from certain other African countries. So those phosphate fertilizers are highly contaminated with arsenic, cadmium, and other heavy metals. So we proposed the origin of arsenic and cadmium in the region is basically phosphate fertilizer. Based on our finding, we propose this 3x3 model. So those are the direct evidences. We have other lateral evidences to support our hypothesis. Male predominance. Why I say like this? Main mode of toxin into drinking water and food, according to our findings. But male are overexposed as there are additional entries, inhalation and percutaneous. And also males are subjected to aggravating factors like heat stress and dehydration. So they are more prone for the disease. You can see how our farmers spray without having any personal protective equipment. And don't forget, they immerse their legs in the toxin-rich muddy soil for a long time. So it's a very easy mode of entry of these toxins to the body. So male predominance of the disease is in supportive of our hypothesis. No disease in the northern province. Why is that? Low amount of agrochemicals has been used in the northern province of Sri Lanka, primarily due to prohibition imposed by the government in this province. The prohibition was due to the potential usage of these chemicals to produce improvised explosive devices. And the IEDs were used abundantly by armed groups of the terrorist movement that brought the country into the 2009 for causing mass destruction. So in the northern province, these agrochemicals were not widely used during the last 30 years. So that area is free of disease. So this is very unique example, evidence to support our hypothesis. Emerging of disease in epidemic scale in mid-1990s. Why mid-1990s? So this is our explanation. Political changes instituted in the late 1970s in Sri Lanka have led economic policies that allowed the importation and application of agrochemicals in large scale, especially for paddy farming. Though low concentration of cumulative nephrotoxins and its bioaccumulation could have taken 12 to 15 years to cause damage to the kidneys, leading up to the level of clinically identifiable CKD or SINAC. And don't forget, JVP insurgency and LTT terrorism prevailed in the farming areas, especially in the late 1980s, forced farmers to use two-wheel mini tractor and herbicide in large scale. So this explains why this disease all of a sudden emerged in mid-1990s as epidemic scale. The increase in prevalence of SINEC and to the shifting of age to diagnose to younger age groups over the years are highly suggestive of the cumulative nature of the toxin. It is well compatible with the known toxicological theories. And evidences from Central America. Central American groups, especially working in El Salvador, they produce data very compatible to our findings. No fluoride, high fluoride level in the Central American region, but their groundwater hardness level is high, very compatible to the North Central province. And also the arsenic, they have natural arsenic as well as cadmium originated from phosphate fertilizer, because this disease basically in the sugarcane farmers, sugarcane and rice belong to the same grass family. The consumption of agrochemicals is very much similar in rice and sugarcane. So the picture in the Central America and North Central province is very much compared. I have been there at least 5 times. I went to their fields, worked with the researchers, and even the environment is very much similar to the Padavi and Sripura. They are in the Leon region in Nicaragua. Recently we did a study this is a 4-nation study, and we presented the study at the World Congress of Nephrology, Mexico City last month, and it will be published as a paper in NDT journal within a couple of weeks. And we found 2 diseases are in Central America and in Sri Lanka is very much similar, not only histopathologically, their urine findings, blood findings, and other novel biomarkers are almost similar in the 2 regions. So whatever the pathology or whatever the etiology for the disease should explain the disease even in Central America. So I feel the fluoride hypothesis or heat stress and dehydration hypothesis alone cannot explain the disease in both regions. And our hypothesis is more compatible to explain, more coherent and consistent to explain the disease in 2 regions. And early renal anemia, an excellent study done by our hematologist, Dr. Vasana Mendis, very recently found these patients are presented with early anemia. CKDu patients, SINEC patients presented with early anemia. This is compatible with known knowledge of the toxicology. Ita disease in Japan, they presented with early anemia. Why is that? Because erythropoietin producing cells in the renal tissue is located very close to the S1 segment of the proximal convoluted tubule. So any toxic insult to the S1 segment of the proximal tubule damaging erythropoietin producing cells, it resulted in early anemia. These patients in the Anuradhapura, they presented with early anemia, and it is well compatible with known toxic origin nephropathies, especially with cadmium poisoning. So Dr. Gamampilla, you may be very happy with our findings because he's a good supporter of cadmium hypothesis, and also recent increase in the cancer prevalence in the SINEC endemic region. We as people, academics working in the region, we observe high prevalence incidence of cancers in the Anuradhapura and Polonnaru region, which is also overlapped with, it is well overlapped with the SINEC endemic regions. 2 physicians working in Anuradhapura here, Professor Siripadhan and BP Prasanna Veeravansh, they will give evidence that small kids with leukemia and lymphoma prevalence is very high. The females and males, prostate cancers, breast carcinomas, and other various carcinoma incidences are very high. So this can be the SINEC and high incidence of cancer may be linked to the same etiology. Because don't forget, inorganic arsenic is the #1 human carcinogen. Cadmium is human carcinogen. Glyphosate is group 2A human carcinogen. Paraquat and other chemical substances are identified as carcinogenic substances. So these lateral evidences are there to support this disease is basically due to the usage of agrochemicals, and etiology is linked to the agrochemical. Those are lateral evidences. So I feel I have given enough direct and indirect evidence to support our hypothesis, and And please, Chairperson, sir, give me 2 minutes to summarize what we have done at Rajarata, and we have at least 4 collaboration with other universities, with University of Colombo, University of Kelaniya, University of Pune, and Open University, and with the now Sir John Kotalawala Defense University, and with the Syntec even. So we have 3 basic international collaborations with the Karolinska Institute, Sweden, and Antwerp, Belgium, and Rajarata we have direct collaboration with National Institute of Health, El Salvador, and Cuba. So this is our group. We did a very good study there in Polonnaruwa, comprehensive study with the help of Dr. Rajiva, excellent clinician, nephrologist in Polonnaruwa. I don't know whether he invited to this meeting. I feel he should be here. As far as I know, he's the one who did highest number of renal biopsies in CNAC patient in whole world. And this is the collaboration with Antwerp, Professor Mark de Bro. He is the world authority of nephrotoxicity, and the El Salvador and Cuba collaboration with the government blessing. We not only did research, we effectively use our findings to change the lifestyle of people based on 3 principles: minimize exposure to nephrotoxins, provide safe water in adequate amounts, and promotion of organic farmings. You can see we addressed all possible hypotheses, including fluoride and and dehydration. So we did public awareness and medical doctors awareness. Personally, I have addressed more than 250 meetings for the last 5 years in the region, and we also generated pressure on politicians and government officers, and we laid the foundation to establish the Presidential Task Force for the Prevention of Kidney Disease, where I was the first director of the Presidential Task Force in 2030, and we take effective measures to prohibit pesticide promotion in electronic and printed media. So now you can't see any advertisement in television or in radio, further or in the printed media, and some of the agrochemicals were banned. Certain people believe this is due to a hypothesis paper, but I have to say this ban was proposed and agreed on the cabinet about 9 months before the publication of our hypothesis paper. So government-sponsored program to promote organic environmental friendly farming was introduced, and also we proposed CKD, RO water for CKDu, reverse osmosis water, to provide good, clean drinking water in adequate amounts. This RO water was first introduced by an engineer, but we adapted the concept RO water to CKDu. Initially, we had some doubt whether pure reverse osmosis water produced some other problem because of the lack of salts. Now we introduced remineralization unit, and we published how effectful the reverse osmosis plant in the region. And you might have aware about this project. It's basically conceptualized by me. Derana Daru program. Now more than 2,500 students are benefited from this project, and 3,000 monthly allowance for each patient. Basically developed over the last 3 to 4 years. The basic proposal came from Presidential Task Force during 2013, and now it is implemented. And I hope we, as the only research and higher education institute located in the disease endemic region, we have done our maximum in our capacity to reveal the etiology, to help the people in the North Central province and adjacent provinces. And I would like to finish the presentation. These school girls are from Padavi Sripura School. We launched a Kanda program, herbal porridge program with the help of Sri Lankan Doctors Association in Southern California, and it is there for last 2 years, and they are receiving herbal porridge prepared out of traditional rice 2 days per week, and it's very effective program. So thank you very much for listening to me.
Thank you very much, Channa, for that excellent presentation. Well done. I think you've done a lot of work. Congratulations. May I now invite Professor Mangala to do his presentation. After that, we'll take the...
තව කම්ප්ලිමන්ටරි දෙකක් තියෙනවා අපි ඒ දෙකක් මේකේ කරනවා කම්ප්ලිමන්ටරි ටික මේකේම
අපි ඩිස්කෂන් එක කරලා නැත්නම් මේ සිස්ටම් එක කල්යන්න නැත්නම් let him we'll do it no problem but we'll do it in system we'll do it no problem ඒක මේක ට්‍රක් එක
මේකට මැග්‍රිවල්ස් දාන්න
ආගේ කරේ ඊට පස්සේ හරි no problem කවුද ක්ලාස් Etiology හරි
Good morning, Chairman, the University Grants Commission, and respective ladies and gentlemen. So I'll be a little bit different from Dr. Chan Jayasumana because particularly in this talk I will be speaking about the emergence of chronic kidney disease of uncertain etiology in southern and Uva provinces, an environmental and toxicological approach. So based on this series of studies that we have conducted in southern and the Uva province, so basically we had a scientific approach to tackle the CKDu disease in emerging locations in Sri Lanka in south and in Uva province. So we had basically environmental approach and also the clinical approach. So under the environmental approach, so we were focusing on the identification of coercive agents through water quality analysis, pesticide residue analysis, heavy metal analysis, etc. When it's come to the clinical approach, so we were based on the diagnosis, the CKDu at very early stages by using the urinary biomarkers first time in Sri Lanka. So basically looking at the study locations, so our group is quite different from the North Central province groups. So basically most of the groups are concentrated on the NCP. But basically when we are looking at the socio-economic status or the environmental variability in different locations in Sri Lanka, so we were questioning ourselves. So if the disease is prevalent in NCP, why not in southern and Uva provinces where the environmental conditions, farming practices, socio-economic status are pretty similar. So as a non-endemic controls, so for the whole study series, so we were concentrated on the Matara farmers as non-endemic controls, and Nuarelia, so we know there are no SINAC patients in Nuarelia, although the heavy use of pesticide and all those things are there. But particular attention was given to the Mondraga district in Uva province, 2 locations, Warunagama and Rahatangama. So these are GS divisions located within the Palavatta sugar industries premises. These people are resettled people from previously resettled people. Actually, if you go to these specific places, you can see how much the industry has given the priority to the people. Basically, these are like a human fence for the elephants. So the human settlement is there, then the sugar cane is there, and the elephant is beyond the human barrier. So the settlement itself creating problems, and the groundwater quality is a problem. So a lot of hard water and a lot of wells with the tube wells they are using. So we are particularly looking at the Warunagama and Rahatangama. So basically they are sugarcane farmers. So we are the first group to understand the SINAC cases in something similar to the Mesoamerican nephropathy, because basically they are sugarcane farmers. So we hypothesize, so why not among our sugarcane farmers? And the next 2 locations from south, of course, we know in the WHO study, the southern province was selected as a control location, but we have a doubt because despite of the different locations have the hotspots, we purposely selected Bandagiri and Agunukola Palasa because Bandagiri is a paddy farming, mostly famous for the paddy farming, and Agunukola Palasa is both basically these low country vegetables or otherwise a paddy. So basically for the whole study series, we were concentrated on these 4 new locations, Warunagama, Rahatangama, Bandagiri and Agunukola Palasa. Not only these 4 locations actually, many of the GS divisions surrounding these areas. So what we have done is actually to support the agrochemical nephropathy. So we have gone for the glyphosate and paraquat measurements using the ELISA methods, and what we found is like glyphosate and paraquat measurements. So that to support them is clinically, so we measured all these creatinine, EGFR, microalbumin, HB1C, and the other parameters. So what is novel in this study is that we are the first group to use the urinary biomarkers. At University of Ruhuna, so we use ELISA technique to detect urinary KIM1 and INGAL levels measured using specific KIM1 and INGAL ELISA kits. And it's a sandwich ELISA assay program. So after looking the promising results, so when we get the promising results, so we were thinking about going further extended one. So the ELISA is a basic technique, but it's a good technique and quite expensive as well. Then we went to further way to the microbead assays. That is pretty straightforward, bit cheaper than the ELISA techniques. And we had a collaboration with the renal division of the Harvard Medical School, Boston MA, where with the Professor Joe Bonventry. So he has the patent for the urinary KIM1. So the study was pretty much easier with us. And all those statistical analysis for the whole program. So these are the basic things. So I will just keep it. And the most important thing is results and discussion. So particularly we were looking at these farmers, pesticide using, handling and awareness. So it's matched to the what Dr. Channajaya Sumana explained previously. So the basic characteristics of these participants. So below 20 years, education. So basically they are primary educated people. So their knowledge is quite good. And occupation, farmers, farming type, sugarcane in Rahatangam and Varunagama, and also the paddy in Matara, Angunukunapalas and Bandagiriya. And smoking, the lifestyle, very common factors, smoking, alcohol and beetle chewing. So that are the common among the men, and it's very common among these farming communities. And particularly looking at the agrochemical practices. So the use of agrochemicals was common among male farmers, and usually it's the dealers usually suggest recommendations, not the agricultural extension officers. I think there are no agricultural extension officers so far in this country, and overuse of agrochemicals was common to the survey that we have carried. And the most important thing is, although they have the awareness, the handling of agrochemicals is rather doubtful. The awareness of side effects are very high. So they know what they are really doing, but they don't practice it. Especially when the mixing comes with the different pesticides, though they mix the different herbicides and pesticides on site with the no safety. So these are perfect chemical engineers, I feel. So they mix very commonly glyphosate, urea, MCP, glyphosate, urea, MCP, then they have the MSD come to the scene. So the mixing basically available throughout this region, but compared to the NCP, it is very straightforward. They use lesser amount of pesticide types, so we don't have to go worry about these things. Basically, it's a glyphosate as a herbicide, and basically it's a diurone as a fungicide, and the most common mixture is actually a glyphosate and the diurone for the sugarcane farmers. And after using, so either they dumped in the field, or sometimes even these people, so they reuse these bottles at home. And the drinking water source, so we know that most of the studies are as a carrier has paid attention on the water as a carrier. But we should not forget about the dietary exposure as well. But we cannot ignore the drinking water sources. So if you look at the Matara past and the drinking sources, so we divided this past and present is the 10 years back means the past, and after that is the present status. The Matara farmers, so throughout the past and the present time period, so they got the tap water. But if you look at the Varunagam and Rahatangam, the problem comes there. So they don't have access to the tap water in the past. Basically, they are depending on the wells and the tube wells. And sometimes even the Rahatangama, the situation is worse. Even they drinking spring water from the branch of Kirindioya, where even the industry is putting a lot of garbage and all those things. So it is a significant proportion. It's 19% this one. And the Agunukonapalas and the Bandagiriya is the same picture we can see during the past. So basically, they were using surface well water, and Bandagiriya is around 97%. Actually, now the Agunupalas and Bandagiriya, so they are in some areas, they are getting the water from the community-based projects. So the water as a carrier, so we cannot forget, and so we did the water quality analysis for some factors. I'm afraid you cannot see the values sometimes, but basically looking at, I don't see any much difference with the water quality parameters with the zone 1, that is Matara, zone 2, Nuvarelia, zone 3, that is the Ratangam and Varunagam, and zone 4 is the Agunukonapalas and Bandagiriya. So if you're looking at the hardness, so both emerging locations, so they use pretty much hard water, very hard water in most of the wells. Actually, the easiest thing is in these blocks is very easy, because you can sample all the surface wells and tube wells present in this one. So as and basically speaking, Rahatangam has only 35 water sources. These 35 water sources, if you do the detailed analysis, so you can find this one. And fluoride also, in some wells, fluoride was exceeding the standard levels, but basically most of the wells, so it did not exceed the fluoride levels. And also we did glyphosate levels in groundwater samples. So like the Matara, so we did only 5 water sources, because basically they are getting the tap water, these farmers. But Rahatangama, as I told you previously, so there are a limited amount of water sources. Rahatangama, there are only 29, and Varunagama is a bit more than 14. So we found certain amount of glyphosate levels in groundwater samples, but not the levels really that we expected in water. But when it's come to when we deviated from water, so we wanted to find out if the water does not carry these nephrotoxic chemicals, so where do they get these nephrotoxic chemicals? So that is their occupational exposure. We know that the sugarcane farmers, so basically their occupation is sugarcane farming, so around 2-3 times for the year. So some people are just keep on spraying. So we did some studies comparatively studies with glyphosate and paraquat, because glyphosate was common until previously. It was given by the industry to the farmers free of charge through the industry, and the paraquat was the most commonly used herbicide previously. The important thing is detectable levels of urinary glyphosate. Remember that they don't find the urinary glyphosate in the water that they are consuming, but detectable levels of urinary glyphosate and paraquat was reported in even in Matara, especially in Rahatangam and Varunagama, with significantly higher differences, but not in Nuwara. And of course, men had high levels of herbicides than women, so it supports the occupational exposure to the herbicides. Another factor than that means the inhalation also play a very important role among the sugarcane farmers. So we didn't stop it from here. So I know it's sometimes maybe it's very controversial. So we want to show, so if we find the urinary glyphosate and paraquat levels in the urine, so how can we detect to the other agents? So in this case, so we use the biomarkers for the kidney injury. So we know that for the certain regions in the nephrons, there are several biomarkers. In fact, you get the highest number of biomarkers for the proximal tubule area. But we try different biomarkers initially. So from that particular, with the ones in the red square, so we screen out the KIM1 and the lipocalin, what you call the NGAL, is a very suitable markers for to find out the tubular injury these farmers. So we, after finding this preliminary results, so we extend our study to we try to relate the occupational exposure of these herbicides to tubular injury. So assessment of kidney injury using urinary biomarkers in KIM1 and NGAL. So you see the two different locations, and on your left-hand corner, it is the kidney injury molecule biomarker, and on the right-hand side, it is the urinary NGAL. So we didn't find significantly difference between the two locations with the KIM1, but with the NGAL, so it was clear that these farmers has considerable levels of NGAL in their urine compared to the controls. So what is more disturbing is, so why do we get higher KIM1 in the Matara farmers? So that is our main concern right now. So we are trying to investigate. So why do they have the kidney injury molecules? Basically speaking, so KIM should not be present in the urine, because the KIM1 is very sensitive and very specific marker. But considering as the levels of the normal standardization with the US population, so our normal farmers in the other regions, so we have more KIM1 in the urine and also in the plasma. So I will come back to that one again in the next few slides. So we didn't stop from there, so we tried to find the association between the herbicide exposure and the urinary biomarkers, KIM1 and GAL. So the first side, so we see a significant relationship between the ACR and this the presence of glyphosate. In the left-hand corner one, so we get the clear association between the when you have more glyphosate in urine, so we have the higher albumin to creatinine ratio. That is the ratio that is the basically the parameter that is used by the Ministry of Health or the other CKDu definitions in Sri Lanka. But when it comes to the NGAL, the four graphs in the right-hand side, so we see very clear relationship between the glyphosate and the NGAL. So as long as you have the glyphosate in urine, so your NGAL levels is going up with a good correlation. So this supports, there's a problem actually, there's a problem, we don't know what is the better marker. But at least in this stage, so we can show that the glyphosate, if you find the glyphosate in urine, so you get the higher urinary biomarkers in urine and plasma as well. And based on the CKDu definition of the health ministry and also from the WHO definition, so we are first reporting the confirmed cases from these locations, Rahatangama, Varnagama, Agunukola Palace and Bandagiriya. So the people might think the sample size is very low. No, actually we started from around 1,700 people, but there are like step by step, so we exclude the diabetic cases, hypertension and other common nephropathical cases. So when we end up with if we are basically looking at these new emerging locations, actually the men comes around 10 to 11%. In the women, it shows as the 33 and 28, but basically looking at the figures of the table, you can see, so it is 6 females and you get 2, so that's why it end up with the 33. So to estimate the real prevalence, I think it is too early. Right now we are doing it, but basically looking at the results after this study also, so we are expecting 8 to 10% of people, the farmers, are affected with the CKDu cases in these emerging locations in the Wu province and the southern province. Then from that aspect, so we keep it aside the glyphosate and the paraquat exposure. So we tried as a detection tool, we try to develop the urinary biomarkers KIM1 and NGAL for the early detection of CKDu, published in the PLOS NDT in 2016. So if you looking at the two graphs, this side is the KIM and the other side is the NGAL marker. So with the you can see clearly the CKDu patients KIM1 is very high, so always they clusters together even with the KIM and even with the NGAL. So what is more disturbing here actually, the population, what is more disturbing is the population somewhere here. So these are basically healthy farmers, but they have considerable levels of KIM1 in their urine. And it's the same for the NGAL as well. So basically all these farmers, so they exceeded the levels of the US population study, that is 500 picogram per milligram creatinine. So basically looking at, so they don't show the disease right now. So we suspect, so still they are in like early stages of CKDu1 and CKDu2. So it creates lot of doubt in minds. So we went to see the traditional markers, the relationship between the traditional markers and the biomarkers. So we see when the ACR is, we get a relationship, the positive correlation when the albumin to creatinine ratio is getting higher and the KIM and NGAL also higher. But we didn't get a clear relationship between the EGFR. So what we know is EGFR is very late one to decide whether they have the CKDu stage 4 and 5. I think it's perfectly alright, but I don't think the EGFR is a good parameter to estimate the SINAC cases in these emerging locations. So basically, then we were further extended our KIM and NGAL study with the collaboration of the renal division at the Harvard MS, where I was a visiting research professor for the Harvard Medical School in the division of nephrology. So there we get the two biomarkers with the bioplex array system. So this is the KIM and this is the NGAL. So these are the CKDu location 1, Dehiyattakandiya, CKD 2, Medavachiya, and CKD locations 2, Padavishripura. So you see if you put the normal range here, it's around 500. So most of our CKDu cases, the Kim and NGAL is quite high. They are separated quite nicely actually. So when we have the control 1 and control 2 and control 3, in the control 1, it is a value of farmers. So they don't have CKDu, these particular 170 farmers. But still you see, they are the Kim 1 levels and the NGAL levels are quite high. So while we are doing these things, actually the Boston University group and the other Mesoamerican, some of the other Mesoamerican groups bring the heat stress nephropathy. So we wanted to try the heat stress nephropathy in our workers as well. We know these are our value of farmers and the construction workers, especially the masons and other construction workers. So they exposed to the similar heating conditions. So what we are seeing is, so the value of farmers, so but they don't have the CKDu. But then this one this one shows us the CKDu, with the CKDu cases, the Kim and NGAL values do not go with these construction workers. If the heatness nephropathy is going to be proven one day, I don't think so, but we should have more high Kim and NGAL levels with the construction workers. And the control through is Agrochemicals still is disturbing, so these are perfectly alright, I mean the healthy farmers, but still they have higher Kim and higher NGAL values. So based on this one, our conclusion, so this is the series of studies that provides evidence for the CKDu disease emergence in the southern and Uva provinces in Sri Lanka. And groundwater quality was below drinking water standards. From our study, we found only the hardness is a real problem in this region. And herbicide residues in farmers confirm occupational exposure, not through the water, but through the inhalation. And biomarkers NGAL at this stage is significantly correlated with the available glyphosate and paraquat levels. And the current case definitions to detect CKDu cases may not be appropriate in CKDu emerging locations because still we have failed to identify the CKDu stages 1 and 2. And these novel urinary biomarkers, Kim1 and NGAL, can be used to detect CKDu cases even at the stage 1, stage 2 of the kidney disease. So with this, all these works, so the research in progress, now many people working with the biomarkers so have the doubt, so we can identify the CKDu cases, but what about these healthy farmers? So we are following longitudinal cohort studies. It's pretty difficult to follow the farmers because we don't know usually where will they end up after recruiting the study. But still we are trying our best to do these longitudinal cohort studies with the Ruhuna Rajaratasinak research teams and collaboration with the Division of Nephrology, Harvard Medical School, Boston in MA. So basically this is to standardize the biomarkers for the CKDu populations in Sri Lanka because we start with nothing, we start with zero. Now we have developed little bit of information, so we want to we use that platform to continue our studies. And interestingly, so basically we are forgetting about the dietary exposure. So I don't think we can forget about the dietary exposure, not only for the CKDu, but for the other cases as well. So we are looking at the micropollutants in rice and different grains and irrigational water and rainwater. So we are getting very interesting results to show our micropollutants in our environmental system is basically it's not natural, so it's basically it's anthropogenic. So we have the links, and again the Ruhuna Rajaratasinak research teams collaborated with the Institute of Global Food Security Belfast, University of Ireland, and also with University of Aberdeen and UK. And particularly also we are looking at the cadmium exposure and the biological effects in sugarcane farmers in Mondragala with the University of Colombo, Ruhuna team, and University of Belfast, UK. So these are the ongoing studies. So these are the published research articles so far. So many articles have been already submitted and already almost published. They are in the press. And these are the published research communications. And with that slide, so I want to say thank you for the listening to my speech.
Thank you, Mangala, for that excellent presentation. I think there is a lot of material you covered and also the scientific nature of your presentation. Thank you very much. And I think next would be for me to get the summary of our repertoire.
I think I will have to present. You may not understand what I have written down in such a hurry.
Yeah, okay. I'll do it. Yeah, just before that, I think Channa is requesting to do a short presentation. I think we will allow that on the anemia component of it. Is that right? And I think that probably will give more insight into our discussion. And may I first invite Vasana Mendes, consultant hematologist of the Teaching Hospital, Anuradhapura.
Good morning to you all, ladies and gentlemen. I consider this a great privilege to have this opportunity to speak a few words on this seemingly simple project on anemia in CKDu patients in the North Central Province, which was carried out by the group of researchers shown. As you may all well be aware, anemia is a well-known and invariable complication of chronic kidney disease. Anemia is said to occur when the hemoglobin concentration of blood falls below the expected levels for the age and sex. And the cutoff levels of anemia for adult males is considered as 12 grams per deciliter, and for females 11 grams per deciliter according to the WHO criteria and European best practice guidelines. How is it that anemia occurs as a complication of chronic kidney disease? It is because lack of erythropoietin. Healthy kidneys produce erythropoietin, which is a hormone responsible for activation of parental red cells in the bone marrow to divide and differentiate to produce their progeny of red cells. To give you a little reminder of the exact location of production of erythropoietin in the kidney, it is produced in the peritubular interstitial cells located near the proximal convoluted tubule and the glomerulus. So, renal damage with consequent damage to erythropoietin producing cells in the kidney lowers the kidney's ability to produce erythropoietin. Thus, less red cells are being produced, leading to lower levels of hemoglobin. Anemia thus developed is widely termed renal anemia. And in hematological terms, renal anemia is characteristically normocytic and normochromic, which means the mean red cell volumes are normal and the mean red cell hemoglobin content is normal. These parameters, MCV and MCH, are indicated in full blood counts produced by automated cell counter machines, which are used widely in patient investigation these days. Yes. And a point of note is that to label someone as having renal anemia, there should be no concurrent causes of anemia, of normochromic normocytic anemia. For example, active bleeding and other chronic diseases. And of course, I have included deficiency anemias here as well because it's a very common finding in our population in the North Central Province. Deficiency anemias in the sense iron deficiency anemia, vitamin B12 deficiency and folic acid deficiency. But I must mention the fact here that deficiency anemias leads to abnormal red cell indices. That means abnormal MCV and MCH. The objective of this study was to determine the prevalence and pattern of worsening of anemia with disease progression among CKDu patients at the teaching hospital Anuradhapura. The study was a descriptive retrospective cross-sectional study. 306 patients who attended the CKD clinic in teaching hospital Anuradhapura were recruited for the study and interviewed. They had variable lengths of clinic follow-up from 2012 to 2016. Just to go through the inclusion criteria, all patients were patients diagnosed with CKDu by a consultant nephrologist at teaching hospital Anuradhapura, and they were not suffering from any other chronic illnesses such as chronic infections and connective tissue disorders. They were not on erythropoietin, nor they had any evidence of active clinical blood loss. They had never had blood transfusions. 5 MBBS qualified doctors interviewed the patients and collected data. The interview-administered questionnaire carried information on socio-demographic characteristics, details of the disease, information on anemia and blood loss. Data on results of serum creatinine, hemoglobin, MCV and MCH were recorded on each clinic visit from every patient. These data were extracted from the set of reports the patients carry with utmost care when they come for their every clinic visit. And the file contained all reports from the data presentation up to the current clinic visit. So to take you quickly through the socio-demographic findings, most patients were found to be male, 83%, and most were of 50 to 70 years of age, and the vast majority were employed as farmers. The next step of analysis was to try and determine the prevalence of anemia by looking at the baseline anemia status. In other words, anemia status at presentation. So out of a total of 255 male patients, 157 were found to be anemic, with the percentage amounting up to 61.57. And likewise, out of 51 females, 38 were found to be anemic, with a percentage of 74.51. But these were all patients who were anemic at presentation, disregarding the MCV and MCH. The next exercise was to try and deduce how many patients were suffering from normochromic normocytic anemia. Out of 157 anemic males, 102 had anemia with MCV and MCH in the normal range. That means, in other words, in this study group, it could be considered as renal anemia. So we have found out that 65% of anemic males had renal anemia, and 68% of anemic females as having renal anemia. This table shows the percentages of patients having renal anemia out of the whole study population. So 40% of males and 51% of females in the whole study population were found to have normochromic normocytic anemia, otherwise considered as renal anemia in this study at presentation. This exercise was really interesting because we tried to find out the level of kidney impairment when anemia sets in these patients. So for that, we used EGFR as the marker of kidney function. EGFR was calculated using the MDRD formula, and EGFR and hemoglobin was plotted in graphs for males and females separately. The male distribution is shown in the graph on the left-hand side, and the female distribution on the right-hand side. The red line depicts the trend line showing the relationship between the two parameters. And the dotted line represents the threshold of anemia. So, the results were the average EGFR at which anemia develops in males was found to be 32 milliliters per minute per 1.73 square meters. And the average EGFR at which anemia develops in females was found to be 34. This seems to be very interesting because in CKDu we can see that the onset of anemia occurs in stage 3B instead of stage 4 or 5, as is usually seen in other traditional CKD forms. These two graphs just shows the trends throughout the study period over time. The trends of EGFR and hemoglobin. There was a significant decline in both parameters, with average decline of EGFR being 1.6 per year and average decline of hemoglobin being 0.28 grams per deciliter per year. So let me wind up my brief presentation with comments on the observations of this study. Firstly, we found out that a significant proportion of CKDu patients suffer from renal anemia, figures being 40% for males and 51% for females. And interestingly, CKDu patients are found to become anemic at stage 3B of the disease earlier than seen in traditional CKD patients. And in keeping with EGFR trends, anemia was seen to progress throughout the course of the study period. Yes. And this leaves us finally with thoughts stemming from the observation that that anemia sets in early, whether renal anemia in CKDu, is linked to the etiology of CKDu. Is it indicative of damage to the proximal parts of the nephrons rather than the distal parts of the nephrons? Thank you very much.
All right. I think thank you very much, Vasana, for that presentation, and we will. I think we are coming to the time for the discussion, which is 11 o'clock. But there is a very short study which I think probably add light to the discussion, which I think I would love that within 5 minutes to present. It's on the radiological evidence, the ultrasound evidence of chronic renal disease of unknown origin. I think who's going to present here? From the Kotlawala Defense University, and he's going to give us his findings on the radiological status of chronic kidney disease, and that probably will add. But I would like to tell Dulita that you'll have to be very fast because this is extra thing, and I think that will fit into our discussion. But I think we'll have to stick to the time. Thank you.
Thank you, sir. Thank you very much. I'm representing the Biomedical Imaging Research Group at Department of Physics, University of Colombo. Here, we know that we have a problem, and CKDu is asymptotic, and until at least 2/3 of the kidney, 2/3 of the functional capacity of the kidney is lost, so we cannot find it till then. So our challenge is to identify to identify the patient at high risk of loss renal function early in the disease process. So here we are going to use physics aspect to help out these patients to find them at the early stage. So our goal is to identify novel ultrasound parameters of CKD based on radio frequency data and develop a technology to measure it. So as Papi Boer et al. Said that kidney fibrosis occurs virtually in every type of CKD and leads to a progressive and irreversible loss of renal function. So this is what we are going to focus on to look at the fibrosis. So our hypothesis is to diffuse kidney fibrosis develops at early stage of CKD and worsen as the disease progresses. So we hypothesize that with the fibrosis, the elasticity of the kidney will lose. So we have invasive and non-invasive methods to detect fibrosis. In fact, if you take renal biopsy, which is not feasible for to measure in Sri Lanka, and if you take the non-invasive methods, for example MRI, again it's not feasible, especially in the Rajarata case. And when it comes to ultrasound, we have a transient elastography method where we cannot use it for kidney problem. Well, we can do it for liver maybe, but not feasible for the kidney. And acoustic radiation force impulse, ARFI, and SWV. Again, scientists have proven that it's not feasible for CKD. Well, our approach is to use a radio frequency echo or RF echo data. So we know that if there's a fibrosis, and there will be speckle patterns in the RF echo signal. So that is what we are going to focus on, the speckle patterns of the RF echo signal. And using those speckle patterns, we are going to reconstruct a B-mode image to see the ultrasound texture. So for that, we are fortunate enough to have a grant from NRC, which is 2.7 million grant, and the PI is my supervisor, Dr. Wansapura. And now this is what we are focusing on. Now we have kidney fibrosis, and we are going to see the relationship between kidney fibrosis and the texture. At the same time, we are going to see the ultrasound RF signal. So if we can figure out the relationship between kidney fibrosis and the ultrasound texture, and the relationship between the RF signal and the texture, we are planning to build a new device to identify CKDu at early stage. So here, this is what currently we are doing. So to identify the relationship between kidney fibrosis and the texture, we are currently doing clinical studies. So from that, texture parameters that correlates with kidney will be studied. And then we will do ex vivo or phantom study and simulation study as well to see the correlation of texture and the RF signal. So again, we are doing a research to see whether we can develop an ultrasound probe so that we can measure the level of CKD. So in our group, 3 MPhil students working on these 3 areas: clinical study, ex vivo phantom study, and development probe. So 3 students working on that. And this is the ex vivo phantom study. So this is the part what I'm concentrating on. We have already purchased transducers and parcel receivers and everything. Now it costs like 1.2 million. Now we are in the process of doing that part of the research. And this is the sketch or the structure of what we are going to develop as a ultrasound probe. So finally, what we are expecting here is, you can see that the left corner, we are trying to build an ultrasound probe which will we can plug into the computer, and that computer will have remote server. So in that remote server, there will be SVM mechanism with trained data, and when we input our data, it will predict or it will tell whether this person is prone to CKD. And at the same time, we are running a different CKDu risk model, and in that model, the goal will be to develop a holistic framework that captures the role of the understanding drives of CKDu risk, from demography and behavior to land and water use. So in that study, we'll get the data, different types of data from patients, for example, environmental facts, biological facts, economic factors, social and behavior factors, and this will be this data will be transformed into the SVM. Support vector machine, and we insert data as numerical values, fuzzy values, and binary values, and that input and then those data will be transferred to again trained SVM. So again support vector machine, and from that we can again we are trying to predict whether we can identify a CKDu positive patients. So even though this looks very simple, it's not difficult at all. It's not easy at all. And to conclude, in this study, we hypothesized that ultrasound texture-based parameters can use to quantitatively assess the severity of CKD. We propose to use the characteristics of radio frequency echo signals to detect CKD. And this is a novel approach as it depends on the fundamental tissue wave interactions. And further, a disease prediction model for CKDu in Sri Lanka using support vector machine will be developed in par with major study. So this is our biomedical imaging research group at University of Colombo, headed by Dr. Janaka Wansapura, and we have 3 senior lecturers, a physicist, and a lecturer, so altogether 4 physicists, and 3 MPhil students, 2 undergrads. And from the Rajarata University, we get the support from Professor Siribadana and Dr. Channa Jayasumana. And from SLEET, we have a statistician, Dr. Darshana Kasurana. So we all get together and try to focus in this study and try to support or help to identify CKDu patients at the early stage. Thank you.
Thank you very much. I think because we've just taken extra 5 to 7 minutes, if I may just tell you that to guide the clarity of our discussion to follow, the 2 presentations, the anemia presentation and the ultrasound presentation, I think basically was complementary to the 2 main presentations. So I hope the reviewer, the rapporteurs and the reviewers will concentrate on the 2 main presentations rather than the others. But at the same time, I must really congratulate the 2 presenters, the last 2 presenters, for the excellent work, especially the early detection by using a novel non-invasive technique, which is the way forward for any form of situation when early detection is necessary. May I now invite the rapporteur group representing to make the comments on the first presentation and the second presentation. I would like them to make it clear to follow the format or the template we have given, and based on the template you could do it for the first presentation and second presentation. That will form the basis for our discussion to follow. Thank you.
Thank you very much, sir. The first presentation on evidence of agrochemicals on etiology of chronic interstitial nephritis in agricultural communities, CINAC. At the outset, I must say that the presenters also did not follow the template very much, so we were more or less taking down notes and when we went by. So, yes, I suppose the presentation was, the presenter started by giving reasons for using the title Chronic Interstitial Nephritis in Agricultural Community. He described the patient's history and characteristics like toxic nephropathy, then aggravated by heat stress, and then it's said that it's caused by chemical nephropathy. He proposed a 3x3 model for epidemic. He also proposed hardness as an hardness of water as an etiological factor. Fluoride was highlighted as not recognized factor. He gave evidences from other countries and reasons from Sri Lanka. But when combined with cadmium, it can be aggravated, he mentioned. The presented case control epidemiology study conducted in Sripura presented risk factors using bivariant and multivariant analysis. Then he described CINAC versus pesticides, that is glyphosate and paraquat in particular. He presented analytical study of well water for cadmium and arsenic and he found that they were within the WHO limits, supported by publications on glyphosate association among human and animals. Other evidences of hair samples taken from farmers and housewives were also presented. Then he went on to do the clinical part, that is urinary and histology. He identified 4 major toxins, arsenic, cadmium, glyphosate, and paraquat in urine sample. Proposed simultaneous exposure to multiple heavy metals and glyphosate to contribute to CINAC. Arsenic and cadmium, he proposed that it came from the TPP, that is triple phosphate, as the source of heavy metals. He also presented lateral or indirect evidence which indicated that male affected more, and non-use of agrochemicals in northern province, where he showed that there is no such disease in those areas. And he also attributed to large-scale importation after 1990s. And comparing all the evidence from Central America being, they are comparable, histology, urine, blood findings. Then he also highlighted the recent increase in cancer prevalence in those areas with CINAC, epidemic regions. He highlighted those collaborations, and he also showed us what preventive activities are taken by their group. That is the end of what I have taken down from the first presenter. I hope I did justice to those presenters by such short time. The next presentation, the second presentation, actually gave the study areas southern and Uva province. They have had 2 approaches. One is environmental approach, where he did water quality, in which he analyzed heavy metals, and the clinical approach, where he used urinary biomarkers, and he presented the study locations compared with the North Central Province cases. And Mathura has been used as a control, non-endemic control. So he described the study population, that is, they are resettled communities, and the groundwater is hard water. compared with the Mesoamerican farmers of sugarcane and rice cultivation. Then the methods adopted is actually, he also studied glyphosate and paraquat using the novel urinary biomarkers and clinical techniques. He described them all in details. And then statistical analyses also were described the study group, basic characteristic and lifestyle, agrochemical practices, and awareness of use of agrochemicals and their side effects. So we found that they were much aware of it. And he found that the use of less amount of pesticides in these areas compared to the north central provinces. Then he presented the analysis of past and present quality of drinking water. Past means more than 10 years ago. And then differences were presented in terms of water quality analysis in those 4 areas. No difference. They are hard water. Fluoride did not exceed the acceptable allowed level. Glyphosate groundwater, he presented that they were lower than expected. Presented occupational exposure to herbicides, particularly glyphosate and paraquat. Then showed the urinary analysis, only detectable levels reported. Explained the assessment of kidney injury by using the urinary biomarkers, higher in Mathara farmers, so he said that need to investigate those reasons. Presented estimation of albuminuria and CKDu cases, which is higher among male. Described further studies and results indicating signs of early detections among farmers of these communities. So then he showed that CKDu emergence in the southern and the Uva province. Hardness is indeed a problem, and then the occupational high exposure to agrochemicals such as glyphosate and paraquat. Thank you very much for your patience.
Thank you very much, and that was excellent summary. I really congratulate you. I've done within such a short period to do justice to both presenters. Thank you. Now, may I give the opportunity to the independent reviewers to basically the objective of that is to go through the aspects covered in the epidemiological system. Basically, I think we got 7 points. So who's going to do the presentation?
Yeah, I will start and my 2 colleagues will follow. Thank you, sir. I think I must congratulate the presenters for their nice presentations and the extensive work they have done in the field. To start commenting on the methodological aspects, in the first presentation by Shanna, we didn't see much of methodological details, though justification was quite good and extensive. However, I have these points to mention. Now he has pinned down SINAC as agricultural communities, probably because most of these cases are from the farming community, and we didn't see much description about the distribution of the sample. If we saw the distribution, we could have commented more on the justification of naming it in agricultural community. But I don't doubt his work, but it's just that in the short period of time we could not get that much of information to verify it adequately. And the fact that it's a sudden occurrence in mid-1990s, and he gave a justification for that. I think that's a fair enough justification with substantial evidence for biological plausibility of the occurrence of chronic kidney disease. He also mentioned the geographical selection of the disease, North Central Province mostly, but remarkable exemption of the Northern Province. And he gave a valid reason for that, that these chemicals were prohibited or not allowed to go into that area for various reasons. So with the time gap between the seeing of symptoms and the allowance or starting of using these agrochemicals, it's fairly clear chronologically looking at the causality of CKDu. The hypothesis they put forward is, I think, warrant coming from those research according to what we heard. And hardness of water, fluoride not alone, but with other hardness of water was a fact that is noteworthy. And also glyphosate and arsenic in fertilizer. The information regarding well water and case distribution is not available for us to comment with how much of well water distribution is overlapping with the occurrence of cases. Certainly, he may have all this information, but just that we didn't see it here in this presentation. About the first presentation, my personal impression and conclusion, it's worth serious consideration of the conclusions and the work that is done, and we can look at more details about the methodological issues when we look at the full paper and other details. About the second presentation, that was there were more details about the methodology. There were two groups, comparison group and the study group. Sampling data was available, and the fact that Mathur area also they found urinary glyphosate to be higher, and that is a control area, and we need looking at that seriously, how that happens, and then how we compare between the control group and the experimental group. And they also mentioned that in the results, mixing of different agents can be the causative factor, not just one alone. So it is a kind of multifactorial nature in causality. And it is also occupational exposure, because they said that the farmers that were working in the field were affected, not the other people who were living in that area, not the housewives that much, though their analysis showed that the micro elements, those agents were present in their hair and all that. My colleagues will add a little more.
Thank you very much, and both were very excellent presentations. Actually, we were sort of planning to review, especially focusing on individual studies. But Dr. Jayasuman is he presented a series of studies, and he started with a very good historical background that indicated his thoroughness about the whole issue from the onset and the development. So that's a very good thing. I mean, in a research forum, he was very thorough about the problem from its inception, and that was his background. And also to support his hypothesis, I think he presented several international and national level sort of information. So your hypothesis was basically focused on the toxins or the agrochemicals and heavy metals causing nephrotoxicity and the chronic sort of this SINAC. So that part, I think, the justification and the background exploration was excellent. Then hypothesis was clear, right, to everybody, that he has a very clear hypothesis. Then the study design, since you had several sort of studies, so we actually, as reviewers, we perceived or sort of structured these into three main categories. Like you presented, I think he presented the epidemiological studies, or main epidemiological study because it's very important, because the interventions, we focus on interventions. I think the interventions are focused on the community. So therefore, the epidemiological aspect is good. So that there was one or at least you did one study, probably referred to several studies about related to epidemiological, because the farming, their behaviors, their factors. The second part is, I think, the set of evidence came through the clinical studies, where the urine concentrations and the main focus was on that. And then the last part, I don't know whether it's study or at least you can put it in that context where the certain policies were reflected upon, like the banning of certain agrochemicals. Those also can be, even you presented as facts, probably could have been the policy type of analysis. You can put it in that context. You could have put it in that context where a change in policy would have an impact or an effect on the community. So interventions also should be that way then. So a change in a policy of or a ban made a change in the outcome. So in the research context or scientific context, I think you could have done it that way rather than just presenting the fact, right? With more evidence that these were the policies and the time periods where these agrochemicals or the things were, right? You referred to certain, instances or insurgencies also, how it affected. It was not very clear, right? Why these agrochemicals started in Polonnaru or the North Central province during these certain insurgencies or during certain times. But whatever, when you focus on the methodological aspects, I think your publications indicated, acceptance indicated that they are methodologically okay, but more detail, we would expect more details with relation to sampling. The sample sizes were presented and the analytical techniques. One of the strengths would be that multivariate analysis, because we know that we are really little biased towards one factor or factor of interest. But at the same time, we should not be too much biased, because there may be certain factors which are associated with what we see, but it's hidden because we don't consider, we don't collect data in relation to that. So therefore, the multivariate analysis, it gives more strength, that adjusted for the confounding factors or the factors associated, other factors which are linked with the agrochemical use or the theory or the hypothesis of heavy metals. So, so this adjustment is fine, but we would expect more details, what sort of statistical modeling were used. And this 3x3 model, I was not sure whether it's just a mathematical model or just an explanatory model developed by you, or you followed a particular mathematical model to explain the possible causes and their strengths. True that it is multifactorial, but then interactions is also, when you do the multivariate analysis, there's another thing called the interaction. When one factor, say, is present, probably, as you said, the fluoride or other heavy sort of hardness would be be a factor in the presence of cadmium or arsenic. So that sort of thing. So the interaction analysis is also one of the statistical procedure where you can prove that when certain things are present in isolation, they don't manifest, but in combination, it gives a large effect than they manifest in individual basis. So those are certain statistical procedures that would give more strong evidence for causality. And in addition to that, the certain other evidence for causality would be consistency of findings from various sources, right? It may not be the same center, but that would come later, right? So probably evidence from different sources. Maybe your study also, the second presenter's study would supplement that theory to consistency. And then the biological plausibility, I think you mentioned a little bit about the models which were used in UK and other places to enhance. And that supplementary the study presented, it was well presented by a hematopathologist. Again, it came to a point where the etiology is addressed. But it was not basically focused on etiology, but it came to the point of etiology, a lot more work to do. You said that proximal tubular damage is causing anemia. So it manifests earlier than a normal kidney disease patient. So that generates a hypothesis for the etiology, but didn't prove it. So a lot more work to be done to prove that hypothesis, right? So you are for that study related to anemia. And also the last point was about the publications. I think in that sense you have shown us so many publications which have gone to international peer-reviewed journals so, about the evidence. That were the comments, right, sort of I have noted down. Thank you very much.
I think the second presentation I will comment on that. It was more according to the format that we expected to review these. Our task was a bit easy there, I think. Although we did not hear much details about the background or on justification, the study design also was not mentioned, but it was what I gathered from the presentation was that it looked like a comparative cross-sectional study where you selected about 4 areas and there were two endemic areas and 2 non-endemic control areas, and characteristics in those areas were presented. So there was an analytical design there where which we could use, which could be used to test hypotheses. And the basis for selection of the areas you very clearly mentioned why the endemic areas were considered and why Martha and Aurelia were considered as non-endemic areas. So the comparison of water sources, then water glyphosate content and urinary glyphosate were the main measures, and also urinary biomarkers were compared between the areas. In the results, there was a good description of the characteristics of the study population, but what we would have liked to know was a comparison of the different characteristics in the study populations, because in order to interpret the findings, if we knew the characteristics of the endemic populations and the non-endemic populations separately, it would have been very helpful to identify the causes better, and also to exclude any sort of selection biases and things which would have come in the way of interpreting the results. And also sample sizes were not very clear to us. In one of the tables where you mentioned the prevalence, we saw the sample sizes, but it was not very clear to us whether those were the exact sample sizes that were studied. So what we thought was a clear definition of the study populations, the endemic study population and the non-endemic study population, with inclusion-exclusion criteria of the populations. I'm sure all these details are with you. They were presented. It would have made the interpretation much better. And in the prevalence, there was a slide on the determination of the prevalence. Again, we were not very clear about the source population and the numbers that were in it. That was another thing that was not clear to us. But overall, I think there was a lot of evidence to support the hypothesis that you tested. And I am sure further details, in the publications or in the articles, when they are provided to us, it would help us a lot in interpreting these results, and especially excluding whether there are any biases and whether there are any confounding factors or additional details of the populations and things would be important in that.
Yeah.
One more point about the hematological study presented by Dr. Vasana. The renal anemia prevalence in the clinic sample was given, but it would have been very strong if she had a community sample also for comparison. For some reason or the other, we don't know the prevalence of renal type of anemia in the community also coming very close to the community clinic sample. In that case, then we need to look at it differently. Even now, it is not too late. If you look at the community and get their prevalence level of renal type of anemia, it will be very useful to compare.
Yeah, I must really thank the 3 independent reviewers for the professionalism shown in very independently analyzing what you felt as experts in the presentation, so strengths as well as weakness, which I'm sure will be helpful for us to get the discussion into a professional level of discussion. And I will open the discussion to the floor now. I'm sure Professor Sharif would like to say a few words. Can we have the mic?
Yeah, thank you, Mohan. I think we must first congratulate the 2 presenters and the other 2 persons who gave supplementary presentations. I'm very, very happy that so much of work done locally, like, you know, and particularly Channa has been working for it for a long time. I just want to have one little query from the hematology, Dr. Vasana, who presented. Now, why did you assume that the anemia is due to erythropoietin only? Did you not think that these toxins can be directly toxic to the bone marrow also? What steps did you take with respect to trying to see the difference? Because why should it be just renal anemia? And why can't it be a multifactorial cause for anemia? Is there any thing you can say about that?
Sure. Other lineages of the blood, like white blood cells and platelets, or that's what we know. But however, the point is well taken because the renal anemia is again can contribute through the bone marrow by the bone marrow fibrosis, hyperparathyroidism, various. There are about 10 or 15 mechanisms that
No, because cobalt, manganese, those type of heavy metals are very closely associated with bone marrow function.
Yeah.
So that is really why.
So your point is well taken, but we have studied the white blood cells and the platelets. We didn't have many means or funds to do this was MD board certification research, and we couldn't do those things. But we like to take your advice and do it in future to suggest the bone
just check
marrow
up the literature with the there are other toxic things. Yeah, basically only comment I can say that from the WHO studies and the recent discussions, the international consultations we had in the last 2 years, the definition of CKDu was much debated thing. And none of these speakers said, this is what we mean by CKDu in our studies. I think that was a little weakness of the presentations as I see it. I would like to hear your comments actually. The presenters, 1 and 2.
I think what we felt was to take the questions first and they can respond later. I will write the questions so that there will be a lot of other people who might like to ask questions. Is that okay, John? Yeah. Yes. There is a... Can you have the mic there, please? Mic, I'll give you. Gentleman in the front. Okay. Gentleman in the front, please.
You want me to pass it on, is it?
Yeah, because he asked first.
Okay.
Sir, I'm Gamin Rajwaksa from Peradeniya University Chemistry Department. I would like to express my views in the point of a chemist. Right. I mean, there are plenty of literature regarding the carcinogenicity induced by fluoride. As a chemist, I don't see fluoride itself can make cancers alone, but it does. It does. There are plenty of literature to support that. That's because fluoride is the most electronegative element. You know that in any protein, any enzyme, DNA has hydrogen bonding. So this hydrogen bonding between NH and COOH groups, those hydrogen bonding, fluoride can make the strongest hydrogen bonding. So therefore, fluoride can, I mean, you know, in the enzyme, there are several different types of enzymes: competitive, non-competitive, uncompetitive type of enzyme inhibitions. So fluoride can bind to these enzymes through hydrogen bonding and influence in many ways. I mean, Manju can support us. There are plenty of literature that he has posted on the carcinogenicity of fluoride. Enough, lots of literature is there. So in my opinion, I think it's in a scientific study, we should not be too biased on our opinion. So there are others. I mean, I'm going to make a presentation on this study in Monragal district tomorrow. There I can see that there's a clear difference between fluoride levels of endemic with those patients and the water that they drink from wells and the healthy people. And also magnesium level. So, I mean, therefore, I mean, we can't just exclude by saying that fluoride doesn't cause cancer. There is plenty of literature for that.
Can I just clarify my thoughts on what you just commented, Professor Rajbaksa? Are we referring to carcinogenicity or nephrotoxicity? I mean, you are referring to the carcinogenicity.
There are literature on both, but the main point that the speaker made was that, I mean, there is cancer in that area, and fluoride doesn't cause cancer. It can cause oxidative distress, making RO, reactive oxygen species, ROSs, because this fluoride can inhibit the mechanisms where reactive oxygen species are eliminated from the body. All these mechanisms. That is how it does it. Not directly chemically, but indirectly it does a lot of work. And fluoride is the most abundant, one of the most abundant elements on the earth crust. 90th most abundant element on the earth crust. Anywhere you have OH, minerals with OH, fluoride can be there. Thank you.
The gentleman there.
The question is to Dr. Channajayasumana. Now, you are specifically saying that the disease is confined mostly to the north central province, and the probably hard water and agrochemicals are associated with the disease. Now, of course, we have large number of other areas further east and northwest where there is hard water and very similar agricultural practices and use of agrochemicals, and you hardly find CKDu there. But of course, Professor Mangala has indicated there is probably emergence of CKDu in those areas. But I should refer to the 2013 WHO report, where unfortunately they spoke of certain agrochemicals, and specifically because we are talking of glyphosate, that report referred to glyphosate levels being 3.5% above 3.5% of the patients having glyphosate above reference limits. They did not report what was the figure for the controls. In fact, we reanalyzed the data and found the control area, which was Hambantota, had double the amount of glyphosate and double the amount of other pesticides that were reported in the WHO study. That is a very tricky situation, very suspicious situation. And and northern province, Dr. Chandra, chemicals didn't go the normal legal way, but loads of it came from India through boats and so on. And farmers in the Northern Province. I happened to go there in the heart of the troubled days, and I found a lot of chemicals being sprayed on those fields. So I think that I have serious doubts about. And then glyphosate levels that we are talking of are very, very low, less than 1 part per billion in most situations. And as you know, 41% of the Europeans have some level of glyphosate residues in their urine, and 92% of people in Malta are said to have some amount of residue in the urine. And in Europe, there are large areas of hard water, glyphosate use. Why don't we find this disease at all? And also about paraquat, sir. Paraquat was banned by about, I think, the mid-1980s or late 1980s. And are you saying that you still find residues of paraquat in the people's urine? What are they doing with it? Aren't they flushing it out? What are the kidneys doing? Having it for 20 years? I am no nephrologist, but can that happen? Thank you.
Thank you. Is there any? Yeah, there are. This gentleman in front, please.
I represent the National Academy of Science. I am emeritus professor from University of Peradeniya. I congratulate both speakers, and I must, my comment is about the timeline. Now, Dr. Jayasumana mentioned even as early as 1994, the administrators, not doctors, were able to spot a lot of deaths from CKDu. And he mentioned 12 to 15 years as the period of the disease. So this takes us before 1980. And if you know the situation here, between 1970 and 76, we could not even, there were a lot of restrictions on imports because there was no money to support imports, and between and the Green Revolution, this effect was felt here after 1982, really, 82, when the ex-government made an intensive effort. But during this whole period, even before 1970, there was intensive agriculture in the north. And when you talk of banning of agrochemicals, I don't think. Also, most of the fertilizer was produced by a fertilizer manufacturing corporation, and there was not free import of fertilizer before 1980. But when you talk of banning of agrochemicals to the north, there were specific chemicals like ammonium nitrate were banned. But branded agrochemicals were still being, for instance, glyphosate was freely available. I mean, glyphosate came later. I mean, other branded ones were freely available. Thank you very much.
Thank you. I think the gentleman in front, please.
I'm Manju Gunawardha from Sri Lanka Institute of Nanotechnology. Now, the question is now, with Channa's excellent finding of glyphosate, and I must tell you the ultra-low dosage of glyphosate is behaving completely different to the high dosage of glyphosate, including now our findings that glyphosate in ultra-low doses is not a weed killer anymore, it's a growth promoter. That means it behaves in a different way. But unfortunately the scenario is, since Dr. Sumit is here, the Registrar of Pesticides, now we still get agrochemical residues, banned agrochemical residues in urine. That means, now if you take glyphosate as an example, the half-life is 114 to 120 days, and it converts into AMPA. Now still, that means somehow this country is getting glyphosate and other agrochemicals from various paths. It is available. Now when we go and see, in some areas we can buy 76% of glyphosate in white color cans at a higher price. So if we listen to these researchers seriously, from the regulatory aspects, we'll have to stop these glyphosate and other chemicals coming in, because the most dangerous part is not the glyphosate, the active ingredient aspect of it. The biggest problem is the surfactants. Each and every agrochemical is having various types of surfactants, rain fasteners, and various adjuvants in it. Adjuvants are comparatively much toxic than the active ingredient. So banning glyphosate or banning paraquat might not resolve the problem any agrochemical, generally it is in the range of 35, 40, 50 maximum of the active ingredient, the rest is adjuvants. Adjuvants are much toxic than the active ingredient, number one. Number two, if you take the same glyphosate coming to Sri Lanka and selling in US, the adjuvants are completely different. We are getting down comparatively low cost materials. When it comes to surfactants in glyphosate, we used to get these polyethoxylated amines were the surfactants, but now currently when glyphosate was selling in European countries, those polyethoxylated amines are not the surfactants. They are using modified silicons and very low toxic surfactants and adjuvants. So we have a difference. They treat us differently because when it comes to the cost, they use higher toxic, low cost adjuvants in our agrochemicals. We'll have to look into these things as well. Final thing, sir, one simple thing. As Chandra said, yes, TSP is contributing into heavy amount of cadmium and arsenic. We have one of the best appetite reserves in the world, and we are not using them. And we heard that these authorities are now trying to sell this appetite reserve into another company in order to manufacture TSP locally, which is going to be a huge problem, and we'll have to work on that. Thank you, sir.
Thank you. I think you highlighted 2 points. One is the banned substances appearing in Sri Lanka. One. Second one, these substances with surfactants and the surfactants and the other adjuvants are of different levels, and the quality that is produced that is used in the other European countries. So I think Mr. Sumit Jayakuri is here. I think probably it's nothing but fair to ask his opinion on this. I would like you to introduce yourself. I think it'll be because some people may not know you.
I'm Sumit, the acting registrar of pesticides representing the Department of Agriculture. I think I was going through the presentation, and I'm not going to discuss the presentation so many matters, but try to focus on. Sorry, you are getting okay. Sorry, just to comment on 2 compounds you are talking about, the paraquat and glyphosate. I think paraquat, we basically, with some issues on suicides, so we completely banned in 2011. So we were getting some progressive work on paraquat since 2003, and we had at that time 24% formulation, and we progressively reduced the original formulation, and we replaced with 6.5% paraquat formulation until since we banned 2011. I think that is maximum possible time to use paraquat is 2013, according to the market surveys and availability. And also, I don't know when they analyzed the paraquat from Dr. Mangala's work, I don't know, the time period was not clear, their work, and so that I can't comment on the availability and the residual status. Anyway, both compounds are very strongly attract to soil particles, because both the compounds are very positively charged. And so I don't know, maybe the availability of especially paraquat in environmental compartments are very, very, very impossible, I would say, according to the electrochemistry and the molecular behavior. So we will discuss. And the second one is the glyphosate. I think I admit still we are getting illegally, although we banned legally glyphosate since 2015. And in the morning also, I got a call from the OIC Kalpitiya. So they have raided a load of glyphosate from India through boat. and I am working, and still we are getting some illegal glyphosate to the country because of the heavy demand. I don't know why. There are very strong and heavy demand for glyphosate by the community, and they are selling very illegally and very secretly. So we are working on the illegal matters, and we will see. And also in glyphosate illegal matters, we have 6 or 7 court cases, and we detected 2 consignments from the harbor, the illegal glyphosate in a bulk level. And so I am to intervene the illegal matters and to control pesticide, and what we have banned, and I am getting and I am enrolling with my maximum capacity to tackle the problem.
Thank you very much. That's very, very reassuring. And I think the second question about the adjuvants you answered, because most of these stuff are coming from India. So obviously of different quality. I think that probably answered your question. If we may go back into the presenters part, I think first is the cause of anemia. I think Professor Sharif highlighted that, and I think Professor Siribardhan answered that on behalf of Vasana, so I think we don't have to go into that again. The definition of, real definition of CKDu, I think, you can speak from here. Yeah, you can, you take this here better.
So actually for the studies, we use the definition given by the Ministry of Health. There's a circular issued by the Ministry of Health on 2009 defining what is CKDu. So for our studies, we use the Health Ministry definition. But for the new name, the CNAC, Interstitial Nephritis in agricultural communities, we included the presence of tubular proteins and living in known endemic region or exposed to toxic environment or in agricultural community to the definition. It is published in the paper. I'm sorry I couldn't include it in the presentation, sir. Thank you very much for pointing out that.
So next one is the question raised by the gentleman. I'm sorry you didn't introduce yourself. Can I ask? Parakram Vaidyanatha. Thank you. I think you can answer that.
So you were specifically asking about the paraquat usage. Now even with the glyphosate, Dr. Sumit admitted still the glyphosate is coming to Sri Lanka in illegal ways. But as he said, the paraquat was used paraquat was used until very recently. Maybe not the name of the paraquat. So what I feel is the regulation, when the regulation doesn't work in a system like this, so still we will get the paraquat in it. And you are asking, and also about what the kidneys were doing when the paraquat is going. It's true that is soluble in water, but the simple toxicological point of is the biotransformation within our system. If the biotransformation, if any toxin, if the paraquat or the glyphosates enter the body itself, so it should be excreted to the urine. To excrete it in the urine, it should be dissolved in the water compartment. But it may be the adjuvants and all other things, so it can be dissolved in the lipid component in the body. So when it's lipid component 1, it's not biologically effect, and also it's not passing to the urine. So it takes time. Even in the USA study population, you will see still they get paraquat and all those residues. So they have banned these chemicals, and their bans are so effective than ours, but still they found these things. So specifically this actually the occupational exposure, so the glyphosate and paraquat, so I don't believe it's coming through the water, but it is basically through the inhalation. So I think when it comes to the inhalation and the biotransformation is getting more complex than when it's directly related to the dietary and the watery exposure. So I believe it's something to do with the biotransformation process in the human. So I think the kidneys are perfectly all right. The problem with the compound.
Just a small question which came to my mind about the adjuvants of these substances which are not very, very pure. What is the general opinion about? Because has anyone done any studies on those?
Actually, we are in an ongoing study at University of Antwerp, Belgium. Actually, the recent samples collected from Polonnaruwa and Anuradhapura, both drinking water samples and urine samples, it contains paraquat. Actually, I don't know how it presents, as Sumit said. And at the same time, there are different chemicals supposed to be originated from surfactants and adjuvants are there in the drinking water and urine samples. But sir, it is very difficult to differentiate these substances, as we don't know what is the chemical name or what is the chemical they used as an adjuvant. So in the LC-MS analysis, we can see different peaks for several organic substances, but it is very difficult to identify and name the substances. So we are in the process of differentiating substances, but it will take some time because it is non-targeted screening. But for the moment, what I can say is there are a whole lot of surfactants and adjuvants in the urine and drinking water samples of these patients.
Dr. Vaidyanath, you want to comment on the answers? Anything? Okay, right. Thank you. Yeah.
Dr. Vaidyanath raised a question why there is no such disease in Europe and other parts of the world where glyphosate and other things are used. So if you go to our 3x3 model, I have explained that there should be some background factors like hot, humid climate and low birth rates, poverty, and everything. Everything are in the bottom layer or as a background factor. So those factors are not there in the other part of the world. That is one explanation. The second thing is, although there are hardness and people use glyphosate and other chemicals in New Zealand and in European and Canadian countries, the people, they usually not consume the groundwater in those regions. The problem is our people, they consume groundwater which are very closely located to the paddy fields. That's the thing that makes the difference. And also you raised the question, the certain chemicals they are in the northern province from India. Yes, it's true, there were certain illegal insecticide like endosulfan and other things, so they are in the northern province. But the problem basically is with the triple superphosphate fertilizer. So I don't think fertilizer in huge amounts are imported illegally from the sea routes from India. But Sri Lankan Army categorically stopped the sending phosphate fertilizers to the northern province beyond the Pune front line.
Yes, different
glyphosate, yes. There may be glyphosate, yes, even in the northern province. But after the banning, we did a basic survey and we found 85% of the glyphosate usage is cut down after the banning. So it is there are still 15%, but it is not like illegal and legal business, there's a demarcation. But I don't think that amount is enough to produce that kind of problem. That's why I say the holistic picture, the all other factors should come together to cause the epidemic.
Is there any studies coming from the northern province about the urinary levels and also what the water samples on these substances?
Actually, we have data from northern province yet to publish, and also data from the renal clinics in Jaffna hospital. The CKDu prevalence in Jaffna is very low, 1 or 2%, and groundwater contaminants in Jaffna Peninsula, there are certain chemicals in groundwater, but the thing is, it is very difficult. Now, there are almost 8 years from the 2009. So for the last 7 to 8 years, they consume these chemicals. So we don't know what was the situation they are in before 2009. So collecting samples now in Jaffna and Mullaitivu, it does not say a lot of things because the agrochemical usage patterns and lifestyles is almost changed in the northern peninsula. So it's very difficult to say. I mean, the recent analytical results may not say what is the picture in the early 90s or in the early 2000s.
The fact of the matter is that it's very low prevalence still.
Yes, still very low prevalence. And also I predict if our hypothesis is correct, so the more hardness is there, people in the northern province, nowadays they use extensively huge amount of agrochemicals. The Jaffna community is in more risk. They may get CKDu or SINAC within next couple of years.
It would be a good idea for you to do the biomarkers now in the urine so that you could see what's going to happen in the future.
So with the northern province and the eastern province, so the populations are quite different. So we are performing the biomarker, the urinary biomarkers, especially Kimman and Gell in this particular location. So we see very extremely low concentrations of biomarkers, especially in the manna farmers. So even those levels are extremely lower than the Mathara people. So it's not confusing actually. Something is really going on, because although like it's the same thing that when we analyze the heavy metals, we see that we are talking about the heavy metals exposure in the NCP is quite high, but in fact it is not. You get the highest heavy metal exposure in the southern province, in the Gaul and Mathara rice. So you get high amount of cadmium. But when you get into the Seruvila, Ampar and all those districts, Samanture, you don't get cadmium exposure to the rice in this particular area. So something really strange is going with the Mathara agronomic practices as well. So the biomarkers levels are extremely low with the Mena and the Jaffna populations.
The last question from the gentleman there.
Thank you very much for giving me the opportunity, sir. My name is Senarat Kirivattuduwa, representing CropLife Sri Lanka, the Association of Agrochemical Importers to the country. So my question is on Dr. Jayasumana. While congratulating and appreciating your hard work to identify this deadly disease, the cause of this disease. So according to our statistics, there is not much difference in the sales which we made in the northern area during the wartime and the present day. Because we channeled all these agriculture inputs through Sri Lanka Army, and any of the Sri Lankan government didn't deprive the right to have access on agrochemicals in the northern farmers. So then there is no difference between the current sales and the sales during those days. And also, you mentioned that this disease were reporting in mid-80s.
Mid-90s.
Yeah. The extensive use of glyphosate started after 1998. Even though glyphosate available before that, it was confined into the areas of tea plantation. So then please kindly rethink and study and do survey whether the taking north as a control is a correct thing. Thank you very much, Doctor.
Thank you, Mr. Kirivattudu, for your information. Actually, that's why I say mere presence of a single chemical, whether it's a glyphosate, paraquat, cadmium or arsenic, according to our hypothesis, it does not cause the problem. There should be a mixture, according to our hypothesis. Yeah, glyphosate may be available in the northern province, but not the triple superphosphate. It means the cadmium and arsenic. So these factors should be overlapped to produce the thing. So yeah, and you said glyphosate was introduced in large scale in late 1990s. But the thing is, even before Mahaveli development project, the settlements were started in the Hiyatakande and Girandrukote area. They used glyphosate in large scale to clear the lands. The glyphosate was basically imported by Sipetco with the permission of Sri Lanka Mahaveli Authority. So even before settlements in the region, glyphosate was used in the region, and also not only glyphosate, but it is compensated with paraquat. In early days, paraquat was used in extensive amount. So yeah, we have to rethink certain things, but from the people side, we can detect these heavy metals and pesticide residues in their urine samples and their kidney tissues. So we have to apply the precautionary principle. So we have to protect our people. So we have to do something. I mean, this is, for me, I'm very convincing this is a toxic nephropathy. So for the protection of people and for the protection of children in the region. So we couldn't mention, a recent study shows about 12% of the school children in the North Central Province, they are presented with renal markers. So we have to do something. We have identified certain things. For the protection of people, we may have to take certain decisions. So I propose you to, as a member from the industry, you can go for innovative things instead of using paraquat and glyphosate. Thank you very much.
one small question which came to my mind, sorry, I think we are ready for lunch. The difference as I see it is that what you said is paraquat and glyphosate was available in Jaffna before, and that you agree on that before. But definitely the phosphate-based stuff was stopped because of the army effect on that. So if you compare that scenario with the rest of the country, like the North Central province, everything else was there. So is that what do you think, Chanda?
Yes, sir. That's why I say the combination is the problem, the overlapping. The paraquat and glyphosate, and their residues and surfactants, and from one side, from other side, heavy metals like cadmium and arsenic, and from other side, heat stress and dehydration to a certain extent. In tropical, high temperature region, if you use glyphosate, paraquat, heavy metals from phosphate fertilizers, and if you consume groundwater with contaminated groundwater and foods stuff contaminated with them, they are in high risk. So these factors should be combined. So you can't take arsenic and say this is the problem. You can't take cadmium and this is the problem. You can't take glyphosate and you can't name this is the problem. The combination, synergistic effect seems to be the problem, sir.
I think we have taken 12 minutes of our lunch. I'm sure you can survive. And I'm presenters, the rapporteurs, but especially to the audience for their professionalism in the discussion, which we actually learn a lot. We recognize what we know. We are understanding, trying to understand what is going on here. We have also understood the weak points in our postulates, as well as our approach towards etiological factors. Combination factors is basically the take-home message as I see it in this discussion. And I'm sorry for leaving 12 minutes out of your lunch, and we expect all of you to be here by 1 o'clock. Thank you.
Thank you, sir. There's a small announcement. The live webcasting is now on University of Colombo School of Computing YouTube site. And we cordially invite you all for the lunch served at Restaurant Hall downstairs. Directions has been mentioned outside. We expect you all to be back at the hall by 1 o'clock. Thank you.
Thank you.